Identifying horizontal shifts. We just saw that the vertical shift is a change to the output or outside of the function. We will now look at how changes to the input on the inside of the function change its graph and meaning. A shift to the input results in a movement of the graph of the function either left or right in what is known as a horizontal shift. So here we have our function f of x. And you can see that this graph has been moved to the left. So that is f of x plus 1. Well, the reason why we moved it to the left is, okay, if we take a look at the expression inside here, if we said x plus 1 is equal to 0 and solved for x, we get negative 1. That's why you can see here that it's shifting to the left. Now, if this was f of x minus 1, and we would say x minus 1 is equal to 0, and solve for x, now it's positive, we would shift that to the right. So it's really important to take a look at what's happening with the input. So, for example, if we had if f of x equals x squared, then g of x is equal to x minus 2 squared is a new function. If we solve for x, each input is reduced by 2 prior to squaring the function. The result is that the graph is shifted 2 units to the right, because we would need to increase the prior input by 2 units to yield the same output value as given in f. So a horizontal shift, given a function f, a new function g of x equals x minus h, where h is a constant, is a horizontal shift of the function f. If h is positive, the graph will shift right. If h is negative, the graph will shift left.